All right, so let's start the COBOL. You start at samsclass.info and you click the link for COBOL CTF. And here it is. This is one of the most dreaded programming languages. There was a list that came out of the most loved and most dreaded programming languages. And up at the top of most loved is Rust, and other high ones are Python and Go are greatly desired, and most dreaded is COBOL. Because, I mean, people, it's incredibly old and out of date. It's as old as I am, written in 1959, but it is still extremely important. 95% of all financial transactions are run on COBOL. I don't think most students should learn it as their first language, but it remains important, and I found it very interesting to study. So I wrote a COBOL CTF. So the first thing you have to do is get COBOL, and you can install it on a, whoops, don't need that. You can install it here. It took me a while to figure out how. It used to be in the sources for Debian 9. They took it out of the sources for Debian 11. So you have to add back in a backporting source from Debian Buster, which is 1 or 2 versions back. And this, by the way, creates a machine that the purists hate called a Frankenstein Debian, that mixes packages from the current version of Debian with unapproved packages from previous versions of Debian, which is not best for system stability. But it works for this, and I certainly wouldn't worry about it, but I would do it on a virtual machine, you know, that you can throw away. Anyway, so after you have the old package, you can install it and it will complain. Then you have to do fix broken install and install it a second time, and then it will work. And then you can write COBOL. And I think, in fact, what it's really doing is it's compiling your COBOL down to C and then compiling the C. But anyway, it does make it possible to practice writing COBOL. So the first program, of course, is hello world. Oh, yes, but you want the source code, not the compiled code. This is compiled code. So the source code is the usual sort of unreadable stuff. But there's the actual source code. And let me just clear this and put it on here to be cleaner. All right. So the point of COBOL is that you write English words and indeed English sentences ending with periods. That was the idea. This was Grace Hopper's idea. You would have it uses complete words, not abbreviations. So you have an identification division to your program, and you have a procedure division. And you might have other divisions, but this simple program has only those two. And so the identification division defines something called the program ID, which is just a name for your program. And you see each sentence ends with a period. Then you have a procedure division. Display is what prints on the screen, and you end with stop run, period. So that's the simplest COBOL program, and you compile it with the COBC here and a few choices. By the way, we're using free format modern COBOL. The original COBOL was on Hollerith cards with 80 characters, and you had to have everything indented just the right number of spaces, or it wouldn't accept it, and you'd feed that deck of cards into a card reader and all that stuff. But freeform COBOL no longer enforces the horizontal spacing and lets you write programs in a simpler way like this. So we're using the freeform of COBOL. And so when you run it, it says, hello world. So that's the first thing. And there's a flag defined. So when you got that far, and then we can talk about variables. So let's look at let me clear and look at the variable source code. All right. So now we have an identification division like before and a procedure division, but now we have a data division. This is where you define what you'd call global variables. And it's useful to learn how COBOL variables work. You have a thing called the picture of the variable. So this is what you might call a string in a later language. It is an alphanumeric variable up to 20 characters. And here you have a numeric variable up to 5 digits. And this leads to, I think, one of the most famous things about COBOL, which was the Y2k problem. You store things literally in base 10. It's not like C, where you have binary numbers, and that's how you'd end up with somebody if you were foolish enough to use 2-digit base 10 numbers for the year. Then you would have the Y2k problem. When 1999 turned to 2000, you wouldn't know 2000 from 1900. It's certainly not intrinsic to the language that you had to have that problem. It was just a design decision made by programmers to choose to use a 2-digit base 10. But the thing that confused me about it at that time was I expected the rollover to be at some other time. You wouldn't, because you don't normally store numbers in base 10 in computers. You would expect it to be stored in base 2. And so there would be a different point where it would roll over. But here, you do store it in base 10 and only so many places. So you can define it, you can put a value in them later, or you can start them with an initial value. So this starts with a string and a number in there. And then down in the procedure division, you can define paragraphs, which we'll do more of later, which are a little bit like subroutines. And now you can display a literal string. You can display the name. This is how you do it. Notice you put in a quote, the literal stuff, and then you just put the variable right after it. You do not have a comma separating it or anything. That will display this literal string and then the contents of the variable name. And then the number. Now you can, this is how you reassign variables. In other languages, you would have name equals Bartholomew, but that is, of course, a very strange thing. And I must remember, back in the early days of programming, I remember, like in BASIC, you'd have this in C2, A equals A plus 1. And a lot of people got very upset saying, you know, mathematically, that makes no sense at all. That is not an equation. What is this garbage? And that's the kind of sloppy, shorthand, confusing notation that the designers of COBOL didn't like. This is what you're doing. Move Bartholomew to name. That is a more exact description in English of what you're doing. And so this is how you change the numbers, and now you can print them out again. So if you run that one, you see the literal string, the original name and number, and the revised name and number. So that's how variables appear. And there are other types, and there's a very good tutorial I based all this on. There's various links through here to look at it if you want to go into more detail. Here's the symbols, numeric and alphabetic we talked about. Oh, A is alphabetic, X is alphanumeric. So I should be more careful. I think I defined it here as A. Yeah, so it's not alphanumeric, just letters, not numbers. And then you've got sign and assumed decimal. That's another options I've never used, but you could. All right. So then let's talk about constructing an HTTP GET. A simple exercise, because all you need is some simple text. So get.cobol, maybe it's get1.cobol. Let me do check and see what I called it. I called it get1, okay. Let's do the clear and the cat of get1. All right, so this is just going to create the text for a get. So I define a string called getLine, host line, and carriage return. And the carriage return, I specify, carriage return is an X type with this value. That is a carriage return. So this is a type that is not on my list of variables here. Oh, there it is. Yeah, X is alphanumeric. And you can, this is how you put a ASCII character in. It's going to be 0A sent. It's going to send that raw hexadecimal value. And that will be interpreted by the server at the other end as a carriage return. One thing I might as well mention now, which is kind of mind-blowing, COBOL does not use ASCII. It predates ASCII. It uses the older system EBCDIC, which is different. But anyway, my server on the cloud expects ASCII, and it'll get this ASCII character. So now I make those lines. So this is the line containing get. This is the line starting host. So I put what I want in the get line, and I put what I want in the host line. I could have defined them up here, but I just find it cleaner to do it this way. And now you just display the get line, the host line, and the carriage return. So the end result of all that is it will write out the requirements, that is get1. It will create a get. Now you have to send that get up to the server. With programming outside COBOL, I was not able to figure out how to make a network connection inside COBOL. It is not easy to do. COBOL was never intended for that. COBOL ran on mainframes long before the internet and still runs on mainframes. And creating a network connection to something, while probably not impossible, is really quite difficult. By the way, one thing I wanted to demonstrate in my projects was how much more efficient COBOL is, and I was unable to do it because getting any measure of how much CPU time your one program is using is also incredibly complicated, and I couldn't figure it out because they think you're running a mainframe. They think you have 10,000 jobs running at the same time and many adjustments to keep them all running at top speed. And asking the question, how much CPU time is one little program taking, is not one that's easy to answer at all. However, the reason COBOL continues to exist is that it is by far the most efficient way to do simple calculations like financial calculations, where you have many credit card transactions coming in. You just want to keep updating the balance of credit card numbers. It's perfect for that, which is why financial software is still running on it. So here's how you send it to my server. You use Netcat, and you can install Netcat if it's not already on your machine. And so this will just take that program and take the output of it here, including the blank line, and send it up to my server. So that should be an HTTP GET. And as you see, it is. You get hello COBOL, and you get the Apache header from my server. So that's a simple way to see if you're getting text handling correctly, is to send it to my server. So now you got a few challenges. You have to add the user agent to it here. Change the get line to get the user agent.php, and then change the user agent to COBOL get2, and you'll get a flag, and then change the user agent to flag me, and you'll get a flag me. So just more simple tests to see if you can control your strings in COBOL. And now let's talk about loops, which are going to get us into those paragraphs some more. So let's look at loop.COBOL. All right. So now I give my program a name loop. I have a data division. I have a one-digit number that starts at 0 called num. Now my first paragraph, A paragraph, says perform B paragraph with test after until numbers greater than 3. This is what a loop looks like. And again, it's trying to meet a comprehensible English sentence that tells you everything. So I perform B paragraph, and don't do the test until after you've done it once. So we'll always do it at least once. And the test is until number greater than 3. So the number starts at 0, it'll do it, and then 1, 2, and 3. So if you run that, that's what you get, 0, 1, 2, and 3. And all my B paragraph does is display it and then add 1 to num. It didn't automatically add it. So this is how you make a loop, and this is why you need these paragraphs. And notice that the end of the paragraph is just the period at the end of here. So, all right, and then stop run here. That's the end. So this is like a main routine, and this is the subroutine it calls. You do not need a return at the end of your paragraph. All right. So that's how you loop. And the last part I want to show you is redefines, which did confuse me at first. All right, so here I have a variable called A, which is a 5-digit number. Value 1, 2, 3, 4, 5. Now I have a variable called B, which redefines A and is a 5-digit alphabetical. Now this is strange. So B is now like a pointer. B points to the same data storage as A, but interprets it differently. That's what's going on here. So now I give this an initial variable, but I do not give B an initial value because it should just point to A. Then I add 5 to A, which I can do because it's a number, and then I print them out again. So let's see what this does. Okay, the initial value is here, 1, 2, 3, 4, 5, and A is equal to 1, 2, 3, 4, 5, which, by the way, bothers me a little because the A format is supposed to be alphabetic, not alphanumeric. So I don't understand why it doesn't complain, but it doesn't. And now when you change the number by adding 5 to A, you've changed both of them. They're both pointers to the same object. This will turn out to be useful. If you wanted to change part of a string, you could build a string out of pieces and refer to the individual parts of it, which we'll see later. Anyway, all right, and here's, by the way, another looping method. There's one that looks a little more familiar. Perform varying num by 1 from 1 until num greater than 4. This is the format that looks a little bit more like a classic for loop. Anyway, and there's a lot of challenges to solve here, simple decryption and so on, calculating Pythagorean theorem and so on. So give it a shot. See if you can get some of those flags. I'm going to post this video.